In this video, we will be proving that if we have a circle and we have two congruent chords to that circle, so we have chord here, DF, and chord AS here. If these are congruent, then the distance from the center of the circle to the midpoint of those two chords, those two segments are also congruent. So that's showing it visually. So here we go. Given circle O, AS is congruent to DF, G and H are midpoints. Prove that OG is congruent to OH. Prove that OH and OG are congruent. So here's the proof, and we will be writing it out on the diagram. Circle O, given. AS is congruent to DF, given. So AS right there is congruent to DF over here. G and H are midpoints, given. Then we're going to draw OS, OA, OD, and OF. So OS right there, OA over here, OD, and OF. 2 points determine a line. Then OS, OA, OD, and OF are all congruent. All radii of a circle are congruent. So there, 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 and there. From there, SG, AG, DH, and FH are all congruent. Like divisions of congruent segments are congruent. So SG, AG, DH, and FH are all congruent. From there, OG is the perpendicular bisector of SA, equidistance theorem. So O is equidistant from A and S. G is also equidistant from A and S. So OG is the perpendicular bisector of SA. OH is the perpendicular bisector of DF. Same reason. O is equidistant from D and F. H is also equidistant from D and F. Therefore, OH is the perpendicular bisector of DF. From there, angle SGO and angle DHO are right angles. Perpendicular lines form right angles. So we have perpendicular lines here. So we have a right angle here for angle SGO, and we have a right angle here for angle DHO, both right angles. From there, triangle SGO is congruent to triangle DHO, HL postulate. So we have a congruent leg, these two here. We have congruent hypotenuses there, and we have right angles there. HL postulate, these two triangles are congruent. Therefore, OG is congruent to OH. CPCTC, corresponding parts of congruent triangles are congruent. So OG is congruent to OH. And that is our proof, and we are done.